Okay guys, welcome to the second video on inverse or arc trig functions. Okay, this is going to pick up from page 72. You should see this composition of trig functions page there. Okay, so inverse functions are meant to cancel each other out. So as you can see marked up here, that f of x and f inverse of x cancel each other out and leave you with just that x again. Okay, and vice versa, if you reverse it, it also works. Okay, so what they've mentioned is that, hey, this also applies to sine and arc sine, cosine and arc cosine, and so on, as long as you are within the domain. Okay, so this only applies if you're within the restrictions. Okay, otherwise you have something that's broken, you get something that's undefined. All right, what were those restrictions? Well, we previously wrote a huge chart out for it, but I'm going to help you out by giving you a visual representation that you can always use to help you with this, okay? So if you pretend like we have a coordinate system here, you can write the words sine and cosine connected together like this, okay? And if you imagine that this coordinate system, the bottom number right here, downwards 90 degrees, is going to be negative pi over 2. This is 0, pi over 2, and pi, just like on the unit circle, all right? So the words sine and cosine match up with the inverse function's domain. And what that means to us is when you solve a question with something like, oh, maybe there's a cosine inverse, you can actually just cover up the portion that doesn't have the word cosine in it. So here you see I covered up quadrants 3 and 4. So my cosine answers should have values only from 0 until pi, okay? I can do the same thing with the sine inverse, right? I can cover up this side, so quadrants 2 and 3, right? And I would say that, hey, my sine inverse has answers that go from negative pi over 2 until pi over 2. So what am I saying? If you get an answer that's in the wrong quadrants, that means something is wrong here, that you're actually getting an answer that is improper or in the wrong domain. So you should always go back and check your work. You shouldn't pick answers in that domain. All right, so let's see the chart for tangent and cotangent and secant and cosecant as well. All right. So the chart for tangent and cotangent looks pretty similar. Again, the words need to connect. You're going to have the same angles, except this time we've got cotangent going across and tangent going down, right? So tangent and sine actually have the same domain areas. So over here we've got negative pi over 2, 0, pi over 2, and pi, okay? And finally, we can also make one for secant and cosecant. So I'm going to shrink this a little bit. And we've got secant and cosecant over here. Secant and cosecant. Those match up with sine and cosine. They're actually right with their partner graphs. Right, cosecant matches up with sine from negative pi over 2, 0, pi over 2, and pi. Now, you can think of these areas as being like hot lava, right? So, for example, this could cover up a section over here when you're talking about cosecant inverses, and you need to make sure that you don't touch that green space, because if you do, you've entered an area that you don't belong, and you will get the wrong answer doing that. Okay, so that is essentially the 3 diagrams that you're going to want. All right, so the secant cosecant diagram, the tangent cotangent diagram, and the cosine and sine diagram. Okay, so make a note of these 3 guys. You'll see me put them to use on the next slide. So make sure that you have these down somewhere so that you can follow along. All right, so on the next page, you're going to see a bunch of problems where they're asking you to find inverses. Okay, so what we're going to do, we're going to look at the first one. It says, hey, cosine inverse of -1/2. So what does that mean? I'm asking you, where is cosine equal to -1/2? So at what angle is cosine equal to -1/2? Okay, so what does that actually mean, that it equals -1/2? Well, we can go back to our unit circle and we can find two angles where the cosine equals -1/2. Okay, so those two angles for number one are going to be, we're going to have 3 pi over 4, and we're going to have 5 pi over 4. Okay, so it says there's two solutions basically. Both of those have cosine equal to -1/2, right? Cosine of that angle is equal to -1/2. But one of these is not correct. And if we reflect back on our domain, we'll discover that one of these does not belong, all right? And it's going to be this one that doesn't belong. So I'm going to draw that chart one more time just so we can see it in front of us, okay? So if I'm solving for cosine and sine, so again, the area that doesn't belong here, I can't be in this red section. And that's where exactly where 5 pi over 4 was. It was in a red area. That was down here. So that angle is no good to me. But on the other hand, 3 pi over 4 is up here, which is a good angle. So I can answer that this is going to be 3 pi over 4, okay? And you could also answer in degrees. And in this case, the degree value is just 135 degrees, okay? Now that fits within my domain. Again, so we got an answer that is good. So if we had actually picked the other answer, that would not be correct because that answer would be in the wrong area for this, okay? So the next question now asks me, hey, when is sine inverse of is equal to 2, right? So when is sine of an angle equal to 2, right? When is that going to equal 2? So if you look at your unit circle, you could stare at it all day and you would discover that sine is never actually going to be 2, okay? And if we look back at the domain, you will see that sine inverse says that the domain should have had only numbers between -1 and 1. And guess what? 2 is outside of that area, right? So that is immediately going to get thrown out. We're going to say, nope, that is no good to me. So this has no solution, but we can just say this is undefined. There is no time when sine ever equals 2. And there's two ways to justify it. We can say this is not in the domain for sine inverse, and we can also say that, hey, the sine never equals 2, okay? So that's what we mean by being in the correct domain. So with the cosine, we said my angle needed to be in either quadrant 1 or quadrant 2 between 0 and pi or 180 degrees. And for the second problem, we discovered, hey, I have a number that doesn't exist for my domain, right? That's outside of the area that sine inverse applies to. Okay, so the next two problems ask us to use a calculator to find these trig values. And what you can do is you can click the little trig button if you are using a TI Inspire calculator, and it will have options for tangent, cotangent, so on and so forth, and the inverses for them. So we're going to type this in exactly the way it is on the calculator. So you're going to take tangent inverse of 3.75, and in general, your calculators are going to work this out in radians, okay? So make sure you choose the one that has the inverse. This is important. You really do need this to be an inverse, all right? So when you do this, you should get -0.03, maybe 998, I believe is what you get. Yes. So 0.03998. And that's actually my value in radians. That was very simple. -0.03998. 2.98. And then if I wanted to convert this into degrees, you can think of this as a conversion problem. So this is radians. We can multiply this by 180 over pi, and that's going to give us an answer in degrees. And you should get negative 2.29 degrees. All right, so what are we getting at? That, hey, we have two different solutions for the same statement. One is in radians, one is in degrees. Are they in the correct zone? We can really quickly just check that. Let's draw our picture and make sure. Okay, so here is my small chart. I'm going to say cotangent and tangent. And my tangent value needs to be somewhere in this section. So I'm going to cross out the other section. So negative 2.29 degrees, or that angle that I found in radians, is down here. So that is okay in quadrant 4. Okay, so no domain issues. So this one is good to go. That is a good answer for us. Okay, let's look at number 2 now. So again, we're asking the cosine inverse of 2. And this time they said to use a calculator. So let's go ahead and put that in our calculator. So again, we're going to push the little trig button. And it's going to lead us to a menu where we can choose the cosine inverse of 2. So we're going to say cosine inverse of 2. And what we'll discover is that your calculator will either give you an error or it will say undefined. And again, it's doing that because 2, the cosine of an angle can never equal 2, right? That number just doesn't exist, okay? So our answer for this one is again going to be undefined for each of these because we're just not in the right domain. The cosine values are supposed to be between -1 and 1. So if you have a value that you're putting in that inverse, or you're getting a cosine answer that is in that wrong area, it doesn't make sense. You're just not going to get an actual answer. Okay, guys, now we're talking about these functions, and you can see they've kind of layered them together. They've put the cosecant inside of the arc cosecant and the tangent inside of the arc tangent. And our first instinct might be that, hey, these actually should just cancel each other out, and I would get the same number again back, all right? But the problem is that's not necessarily true, okay? So I'm going to start with the easy one. I'm going to start with number 2 first, okay? So we'll do number 2 first, and we see tangent inverse of tangent of pi over 4. Now, okay, so if we were solving this out and just kind of working through it very step by step and taking it small ball. So tangent of pi over 4, we can use the unit circle, and we're going to discover that that equals 1. So now I have the tangent inverse of 1. And we can go back to the unit circle and we will find, hey, where is the tangent equal to 1? There are two angles. There's pi over 4 and there is 5 pi over 4. And we could do our little domain check to make sure that we are in the right area. So let's draw the little chart one time. We've got our coordinates, and then we've got cotangent and tangent, okay? So tangent only belongs on the right-hand side. So let's cross this area out. So which of these two angles actually works? Okay. You're right, it should be pi over 4. And the 5 pi over 4 is in the wrong location, so we're going to take that one away. So the answer to this is pi over 4. Now you might jump out and say, well, couldn't I have just crossed these two tangents out and said that, yeah, my answer is just pi over 4? Sure, that works this time because this is in the domain for tangent inverse. All right, if this was not in the domain, then we would have a problem because you would actually get an incorrect solution by doing that, okay? Let's see one where that is the case. Okay, now let's look at an example where they don't necessarily just perfectly cancel out. So we've got cosecant inverse of cosecant of root of 3 pi over 2. So that is problem 1 of cosecant 3 pi over 2. Now, the issue here is, again, we're going to realize whoa, this is actually not in the cosecant domain, right? Not in domain. So what happens is that is actually going to lead me to a different answer when I calculate this out. It might be undefined, or we may just get a completely different answer. So that is for cosecant inverse. Let's go ahead and check our diagram to see where our answer should be. So when I take my inverse and I write out my secant and cosecant chart, you see secant goes across the top, cosecant goes around the bottom. Now, one thing to watch out for is that this point on the bottom is negative pi over 2. It is 0, pi over 2, and pi on this end, okay? So 3 pi over 2, while you might say, hey, it is pointing downwards, it's actually not 3 pi over 2, it's negative pi over 2. But let's go ahead and solve this out. So the first thing we're going to do is we should calculate out what does cosecant of 3 pi over 2 equal. So we can go to our unit circle. Remember that cosecant is going to be r over y. And what we get is that this is going to be 1 divided by negative 1, or just negative 1. So now that I've gotten that piece, that's what the inside is equal to. We're going to do cosecant inverse of negative 1, okay? So that is taking this number that we got over here and plugging it back into this outside piece. So when is cosecant negative 1? Well, if we look at our unit circle, you would say, hey, that's actually at 3 pi over 2, but we can't call it 3 pi over 2 because calling it 3 pi over 2 would take us through this dead zone that we're not supposed to go through, right? So we're not supposed to go through quadrants 2 and 3. So if I tried to start from 0 and go around that way, I would be cheating because I've gone through those broken quadrants that I'm not supposed to go into. Rather, what we're going to do is say that that angle pointing downwards is negative pi over 2. Okay, so as you can see, this is different, and you can see this is actually a different number than the original value that I had. Okay, so this is negative pi over 2 as my answer. Okay, now the thing is, those both point at the same angle. Sometimes you'll get ones that have, like a previous question where we had an angle that pointed into a dead area, and you just can't pick that. Okay, but we can't go travel through this yellow zone at all, right? So I don't want to write an angle that will travel through the yellow space. Okay, on to some values that aren't on the unit circle. What do we do when angles weren't on the unit circle? Well, previously we used Pythagorean theorem to determine the values. Okay, so you'll remember my formula, x squared plus y squared equals r squared. Okay, and what we're going to do is we're going to set up each of these triangles based on the information that I know. Okay, so we could pretend like this first problem says tangent of cosine inverse of 2/3. And what that's telling me is that I have a situation where the cosine of this angle is going to equal 2 over 3. And by knowing that, I can tell you by definition that must be x over r. Okay, so I know that my x value equals 2 and my r value equals 3. So let's draw a triangle with this information, and we want to mount this on a coordinate plane, okay? And based on what I know about this, I'm going to keep my domain in mind. So again, cosine belongs in quadrants 1 and 2, and sine belongs in quadrants 1 and 4, okay? So I cannot draw my triangle in any location that it doesn't belong to. So I'm going to go ahead and cross these out. It can't be drawn down there. And let's go ahead and draw our triangle up in a positive direction because cosine is positive. So that's going to end up over here where I can have a positive 2 and an r value of 3. Now, with this information, I can now solve for my y value that I'm missing, okay? So it can be solved using Pythagorean theorem. So 2 squared plus y squared equals 3 squared. And we've got something like 4 plus y squared is 9. And we can continue y squared equals 5, y equals root 5. Now, in theory, we could have plus or minus root 5, but our answer here is only going to be positive. How do we know that? Because if we look at what quadrant we're in, we're going to discover that, hey, this is going to be square root 5, and it is positive. All right, so cosine only had the option to be in quadrant 1 here because it was a positive number, okay? And a positive number means that I need to be on the positive side of the x-axis, right? So I need to be on the right-hand side of my graph, which eliminated quadrant 2 for me. Now that I've gotten the x, y, and r values, I have all 3 values, I can solve for the final answer. Now, this question was asking me for the tangent. So, based on this triangle, can you tell me what the tangent is? Well, tangent is y divided by x. So, I can say that is square root 5 over 2. And that is going to be my tangent value in this case. All right, so let's go ahead and take a look at the next one as well now. So this time we're given cosine of sine inverse -3 over 5. Okay, so for this problem, let's start out by saying the sine is going to be equal to y over r, and I have it negative this time. So I have y over r. So I'm going to say that y is -3 and my r value is 5. Let's go ahead and draw our triangle. So here is my coordinate plane. My sine graph must be on the right-hand side, so I can't be over here. Nothing over there. And since the sine is negative, I know that the y value is going downwards, which means as I draw this triangle, it has to be going into quadrant 4. All right, so I can say this is -3, this is 5, and I'm going to need to figure out what x is. So again, we'll use the x squared plus y squared is r squared formula, and we'll use that to solve for the missing piece. So we've got -3 squared plus x squared equals 5 squared. Notice the parentheses, guys, very important. 9 plus x squared equals 25. And we can continue solving. X squared equals 16. X equals 4 when I take the square root of both sides. Okay, so once again, should this be positive or -4, right? Because technically it is plus or minus. But in our case, we already know what this is going to be. It's going to have to be +4. Because I'm on the axis, the x-axis going towards the right, so I know this is going to be +4. All right, so now that I've got all 3 sides, let's go ahead and solve for this cosine. So what is the cosine of this triangle? It's going to be x over r, so 4 over 5. And that's going to be my final answer here. So you can see, as I was drawing this, I went ahead and locked up quadrants 2 and 3 because of the sine inverse, and I determined that these triangles couldn't be drawn in those positions, which by process of elimination sent me to the correct quadrant, okay? Now remember, you only do this domain check for the inverses, so I did it for sine, not for the normal one, okay? So for problem 1, I did it for cosine, but I didn't do it for the tangent, okay? Those are already fixed, but the ones that are inverses, we have to make sure that we're careful about what domain they have. All right, guys, last question on here, and this one is a bit of a doozy. Okay, what they've done is they've tried to confuse you about this. All right, they've said, hey, can you find the sine of a situation where cosine inverse of 3x? Well, this is exactly like the previous question, except I don't really have numbers. All I have is this 3x. So sine of cosine inverse of 3x. So what am I saying? The cosine of this angle is equal to 3x, which means 3x over 1 is the same thing as x over r. Now this x is the side of the triangle, not the variable x, okay? So let's note our restrictions so we make sure we draw everything in the right spot. And let's go ahead and draw our triangle. So cosine and sine. So I'm going to eliminate the bottom two quadrants. That's quadrants 3 and 4. When I draw my triangle, it must be in quadrants 1 and 2. All right. And since I don't really have a negative sign on here, we're just going to assume that 3x is a positive and draw it in quadrant 1. So this is a right triangle. And my x value is 3x. My y value is unknown. We can always figure that out. And my r value is going to be 1. So how do I solve this now? Well, let's go ahead and set up that same Pythagorean theorem that we used earlier, right? X squared plus y squared equals r squared. Again, this x is like the side of the triangle. So I'm going to plug this in as 3x. That's going to be squared. I don't know my y. And my r squared is just going to be 1 squared, okay? And let's see how this comes out as we simplify it. So first, I'm going to go ahead and square this and get 9x squared plus y squared equals 1. And I'll move this 9x squared to the other side. I'm going to subtract 9x squared. So now I've got y squared equals 1 minus 9x squared, okay? And now, to get just plain y by itself, I'm going to go ahead and solve this and get y equals the square root of 1 minus 9x squared. All right. And I've got a y value now to go with my triangle. Square root 1 minus 9x squared. Great. Now, what was my problem asking me for? It said, hey, can you tell me the sine of this triangle? Well, based on what we know, we've got that sine is equal to y over r. Let's just plug in the numbers. Y is square root 1 minus 9x squared, and r is going to be 1. And if we simplify this down, we should just get square root 1 minus 9x squared. Okay, so this is the same thing as the previous question. The only difference is this one has only algebraic solving. You don't actually have numbers to finish crunching it out and getting a numerical fraction. Instead, we got something that it was in terms of x. But it solves out the exact same way, guys. You draw the triangle, use Pythagorean theorem to find whatever you're missing, and then go ahead and solve it by plugging in the values. Okay, guys, a real quick summary. You need to make sure that you use the domain restriction for all inverses. I went ahead and put all the charts on this page just so you could see them one more time. You're going to want to have these in front of you. And even if you don't label them, at least you'll know exactly which quadrants your answers should be in. Now, this applies to all of the inverses problems, okay? So you want it for things like sine inverse or arc cosine, okay? Or even if you had something like cotangent inverse, okay? So for anything that has that inverse sign, that -1, or the arc notation, both mean the same thing. You must check the domain every time you go through one of those pieces, okay? All right, hope you found this video helpful. Make sure that you work out some of the examples in your book that are similar to the ones I showed you today. That way you can get a grasp of how to solve these yourself.